Okay, good evening to everybody. My name is Dr. Timothy. Today marks another day for our cloud computing class, and we're going to continue from what we stopped last time. And today, I would like you to be more attentive so that we can be able to have more things to gain. It's not about the number of hours we spent, but about what you gain in the class. So, meanwhile, let me share my screen so that you'll be able to have access to what I want to teach today. Please, if you all see my screen, you can just give me a signal, or you can just signify, or just text your message on the message box if you are able to see my screen.
I can see your screen, sir.
All right, thank you very much. So I want to brush up what you have learned. You must have learned something about machine learning before, or probably from the Python class, which you have already learned before. Machine learning has two divisions. Broadly has two divisions. We have supervised machine learning and we have unsupervised machine learning. Though some authors classified it into about 3 to 4 divisions. Some say we have supervised machine learning, we have unsupervised machine learning. Some claim that we have semi-supervised machine learning, and some claim that we have reinforcements. And it's still part of the segment of machine learning. But to me, I classify it as into two. That is supervised machine learning and unsupervised machine learning. When we talk about supervised machine learning, I'm just trying to brush it up again because I know you must have been taught this before now. So I'm trying to brush it up again so that I'll be able to refresh your brain about it. When we talk about supervised machine learning, it's a machine learning that is an algorithm that has both targets and feature variables. So when you have target variable and you have feature variables in your model, then you can now think of supervised machine learning. But unsupervised machine learning, that is when you have only feature variables and you want to determine which of the feature variables best describe the situation you want to solve or the problem you want to solve. That was called unsupervised machine learning. But today, we want to basically deal with the meaning, uses, application, and what have you. Now we have machine learning is a branch of artificial intelligence and computer science, which focuses on the use of data and algorithm to imitate the way that human learn, gradually improving its accuracy. It's a subfield of artificial intelligence that focuses on development of algorithms and statistical models that enable computer systems to improve their performance on a specific task through learning and experience. In essence, machine learning allows computer to learn from data and make predictions or decisions without being explicitly programmed for each specific scenario. When we talk about machine learning, it's a branch of behavior or human activities. So by the time you do more about what is called machine learning, that means you are mimicking or you are imitating what human can do. And all this can be done through previous data. So you must have been given data before we now talk about how to develop machine learning algorithm. So the reason why this course is like a prestige to our cloud computing is just that in our cloud computing, we'll be doing some models, some computing in the cloud, and this will make us to develop some machine learning algorithm in the cloud. So if you want to, because computings are very many, it's very broad. It just depends on the area you want to go into. So when we say computing, so it's very broad, and the aspect I want to go into is how to develop web or how to develop web page, and also how to create a computing mechanism in the cloud. So how can you achieve this in the cloud? That is the area I want to narrow down this course to, so that I'll be able to have a good class scenario. Now, uses of machine learning can be used to predict, that's prediction. Then that make predictions or classification, such as spam, email detection, weather forecasting, and stock price prediction. So then pattern recognition, recognize pattern in data like image and speech recognition. So also the recommendations, they provide personalized recommendations such as movie and so on and so forth. So these are the uses of machine learning: anomaly detection, then optimization, they're going to optimize the process. Then natural language processing, NLP, that is a very good aspect of machine learning. Also computer vision. Computer vision is also a very good aspect of machine learning. Computer vision. So now let me show you this one. I think this one is having a very good okay, sorry. That is unsupervised. I will check it out later. Now we move on to machine learning has diverse application, including that can be applied in healthcare, can be applied in finance, it can be applied in retail, that is customer segmentation, demand forecasting and recommendation systems. The manufacturing can be applied in transportation, energy, entertainment, agriculture, and all human endeavors. So machine learning is applicable in all human fields. Then what are the divisions? Like I said last time, so I told you that some authors divide it into supervised and unsupervised, while some make it to be 3. Some authors claim they are 4. Some authors claim they are 5. So now, supervised machine learning models are trained on labeled data. What do you mean by this? Is just that you must have a labeled data, that is, must have data set that has been labeled already. So where the algorithm learn to map the input into the desired output. Let me give you the example of this scenario, what I'm talking about here. So for example, look at when we look at factors that contribute to student failure in the university system. So in that place, you want to study student failure. That means you have to go back to record, to data, and some data you have to get include the CGPA of every student that graduates. So when we look at the CGPA, that CGPA will be your target variable. That's be your target variable. So while your future variables will be factors that may contribute to that CGPA. What are those factors? Age is a factor. They also probably, you can think about the number of hours you read in a week is a factor. You can think about family background. You can think about probably gender. You can add so many variables. So you can consider them as factors that may contribute to student failure or student success in the university system. So by the time you have all these factors, they are considered as future variables. And you have already chosen the CGPA of students as a target variable. So in that part of the situation, we make use of supervised machine learning. Meanwhile, supervised machine learning itself divided into 2. So the first one is regression. The second one is classification. So when we talk about regression, when your target variable is continuous, that is a continuous figure, like 1.6, 7.4, 3.4, 3.5, 7.6, 7.1, 8.3, 16.4. Those figures, one by one, they are called continuous variable. So if your target variable is continuous in nature, that is, if it comes in a real figure, a real value, then we can make use of regression. Now, if your target variable does not come in real figure, that is, if your target variable comes in either yes or no, true or false, dead or alive, or if it comes in a probably strongly agree, disagree, and other view, if it comes in categorical form, then we can say that is classification. That is classification. It is still under supervised machine learning, but it is classification. But when your target variable comes in a continuous form, like 1.6, 7.8, 18.5, 16.3, 19.1, 7.0, all those figures one by one, they are called, you consider those ones under regression. It is supervised machine learning, but under regression. But if your target variable is in form of classification, that is yes or no, true or false, dead or alive, then it is called classification. So we have numerous regression algorithms under supervised machine learning. We have more than 30. So also we have more than 50 or 60 classification algorithms under supervised machine learning. So supervised machine learning alone has more than 100 algorithms. So people develop algorithms almost often anytime we want to make more research. So now we're going to unsupervised learning. Unsupervised learning. When we say unsupervised learning, we are referring to a situation where there is no target variable. All what you have are feature variables. Let me give you a good example. Excuse me. You may want to study the factors that contribute to students' success. The same thing with the previous one I gave you last time. But if the data on student CGPA is not available, won't you proceed with your research? You have to. You will classify the model under unsupervised machine learning. And there are some specific models we use to do that, to achieve that objective. So that is classified under unsupervised machine learning. If there is no target variable, you make use of what we call unsupervised machine learning. Then semi-supervised learning. That one, semi is, from the word semi. Semi means when it is not fully supervised, it's just partial. You combine the element of both supervised and unsupervised learning, often used when label data is scarce. I think you can see that. So reinforcements. So that is agent learning by interacting with an environment and receiving rewards or penalties based on their actions used in tasks that deal with robotics and so on and so forth. Now we have deep learning. Deep learning too is classified as part of the machine learning. Deep learning is an area that concerns with voice, that deal with images, that deal with videos, that deal with some of these human activities that may not be numerical, but we're going to bring out numerical value from it. So that's under deep learning. So look at the diagram here. Machine learning, supervised. Then you have regression here. You have classification here. You can see the diagram. You can see my diagram here as well. Unsupervised, you have clustering. Then you have reinforcements. Can you see the diagram now? You can see reinforcement. You can see game AI. When you develop game, develop task, robotic navigation. When you develop mobile app, all those ones. When we develop AI robotics, they are all under reinforcement learning. Now we're going to supervised machine learning. It's a type of machine learning where models are trained on a labeled data set, which means that each input data point is associated with a corresponding output or target. The goal is for a model to learn the underlying relationship between input and output. What is my input? Input data, they are ones that call target variable. Output data, input data, they are called feature variables. Output data is the result, which is target variable, so that it can make predictions or classifications on the new unseen data. In supervised learning, the algorithm generalizes from the label example to make accurate predictions on new similar data points. Look at the diagram here that demonstrates how it works, and also the area where machine learning is useful. As I told you last time, I said it can be used in classification and also in regression. And also it is used in what? NLP, natural language processing. So look at the examples under classification: image spam detection, image classification, disease diagnosis, segment analysis, and so on and so forth. So look at the regression. You predict. Then after you predict, then you have what you call forecasting. You can forecast, you can estimate. So, and also under natural language processing, you can do what? Language translation. So chatbots and virtual assistants. All these must have been taught in your previous classes with other courses that deal with machine learning. So now I'm just brushing it up for you again. Division of machine learning. Look at it. Divide into this. Look at it now. So now we now go properly into example. Practice with Titanic data sets. So you too can remember the story of Titanic. Those days, you can see this story were recorded, and from there we brought out these data sets. We have survived. 0 means no, those who did not survive. 1 means yes, that is those who survived. Then we have P class, first class, second class, or third class. We have gender, male or female. We have age in year, this is continuous. And we have us. We have a SP, number of siblings or spouses aboard. So then we have us, patch, number of parents or children aboard. Then we have fare paid for the tickets. We have embarked. That's a port of embarking. Then C means that's a chebok, Q means question, and S means sat upon, which means different towns. So then we have class, equivalent to P class in words. So we have who, we have adult male, we have deck, we have embarked on, we have alive, then we have alone. These are 15 variables are available here. So what will start coding? So from the coding, the first thing you have to do is to import matplotlib.pyplot as PLT. This is a library in Python. And we import pandas as PD. We import what? Seaborn as SNS. Then we have imports sklearn as what? sklearn.linear model. We import it what? What linear model here? Linear regression, then and so on and so forth. Then this one means the warning, to ignore all the warnings. Then you write this code here. So from the data set called Titanic, then we bring out, let's say called Titanic, then we bring out this one out. These are data sets. By the time you load this code from the Seaborn, this code is coming from the Seaborn, SNS. SNS means Seaborn. Data is embedded inside Seaborn. So many data sets are available in the Seaborn. So under the Seaborn, we load data set called Titanic. So that's the code. So after loading it, we have this like this. So now we have it as the data frame df dot edge. Then bring out this one for us. We now want to know the shape. How many rows? How many columns? We have 15 rows. 1 rows, 15 columns. So then the next thing is for us to do data cleaning. Are you with me, please? Is there any question?
No, sir. We are with you, sir.
Okay. I hope I'm not too faster.
Yes,
I hope I'm not too faster, please. Okay, all right. Okay, we're going to data cleaning. So we want to clean it. The first thing for us to do is to write df.info brackets. Then this one will give us how data is. This one survived is an integer. P class is an integer. But sex is an object. That is male or female. It's an object, male or female. So these are the types of data we have available. And also, we now check for missing values. Is there any missing value there? This is the code for it. df dots is null, bracket, then dot sum. That is sum all the missing values for me. So in the survive data sets, there is no missing value. So you have 0. Then you have what? Then The second one is what?
P class.
The second one is P class, no missing value. Sex, no missing value. But age has about 177 missing values. So out of 869, sorry, out of 891, out of 891 rows, so 171 rows are missing. Can you imagine? So we have C, this, no missing value until we get to embark town. We have 2 missing values. Then we have deck as 688 missing values. So how do we handle these missing values? So we have to count it one by one. Then under the deck has a count of what? Of this. Look at it. In the C, 59, B, 47, D, 33, E, 32. Because that deck has several components. What is deck here? Deck is classified. It's classified as what? Deck term. Sorry, deck term. Where is it there? S, C, S, C, C, S, and so on and so forth. So that is deck. So you have all these. You have B, C, D, A, F, G, and so on and so forth. So now let's feed the missing values. So to feed the H is a continuous variable. So for us to feed the H as a missing value, then we make use of this code to feed the H. We find the median to feed the H. The median value will be used to replace those that are missing. Under the deck, we'll use the mode for the deck. Why are we using mode? This is why using mode is just because deck is not a categorical, so it's not a continuous variable. It's categorical. Like C, like A, like F, like E, like B. So the one that occur most will be used to replace all the missing ones. That's why we use mode here. Use mode here. So from there, we write this code. Then from there, write this code again to fill in. So now we check again the missing value. After we have filled it, check again, we see that there's no missing value again. So all the missing value has been filled up. So can we now see? So we now go to data type conversion. We want to convert data types. Data type conversion. So now we have df.info. You can see. Now the next thing is what? Is to cut it. We cut it. We want to have those that want to convert. So we have df.ilog. The ilog means that go to the particular column and try to convert it to category. So this is the code. Now you have df.info again. You can see that changes have been made to all these ones that are floats, that are objects. Can you see now to what? To category. So now the next thing now is to describe, to find the EDA. That is exploratory data analysis, EDA. So the EDA, the first thing under EDA is to know the describe. Describe will give you the description that involves count, mean, variance, standard deviation, minimum, maximum, 25%, median, 50%, 75%, and so on and so forth, of all the continuous variables. Any variable that is continuous here, the value will come up for us. Like age is continuous, SP is continuous, PASH is continuous, fear is continuous. So these are the values. You can see the values. That means under the age, the mean age is 29.39. Standard deviation is 13.01. So you have to know how to interpret that. So that's the average. Excuse me. So the next thing now is to describe the category. So those that are in category, that is those survive, P class, deck, and so on and so forth. We want to know their number, their unique, their top, and what, and frequency. So now we now draw plots, univariate plots for each of them. This is a plot for the age. Look at it. Look at it. You can see that. You can see that. You can see that it's bell shape. That bell shape means that it's somewhat normal. Then you have what? You have this shape again. Box plot for the age again. Then look at this one under survive. Now I draw this code. Look at it. survived, not survived. So after that, then I draw the box plot for each. The other function to identify and replace what? And replace the outliers with the median. So you want to calculate the outliers. So this is the code to find the outliers. This is the code I define. So define replace outliers with median, df, then column name, then write a code like this, like this. All these one must have been taught in your machine learning class. I'm just trying to refresh your brain again. Then I wrote my notes here. You can see my notes. We define a function. So replace outliers with median that takes the data set and the column name as arguments. Inside the function, we calculate the first quartile Q1 and Q3 and interquartile range. For the specified column, when then determine the lower and upper bands. So for identifying what? Identifying the outlier based on IQR. Then from there, we move on to calculate the what? The median value for the column. They usually lambda function will replace what? Any outliers in the specified column with the median value. That's what we have done, and the result has covered. We can also go to regression. Regression using least square method. So simple regression. So we want to have X and Y. Our X is H, our Y is what? As the fear. Because in my question, during your test or your exam, I will direct you to perform all the tasks individually. You know what I said? I want in the individual research. So that I will be able to look at it critically one by one myself and grade you. So this is the code to find the OLS, ordinary least square method for regression. And this is the results. Are the results. From these results, you can see that anyone that has the p-value lower than 0.05 is significant. You can see. Look at this value here. So this value here, 0.00. That's the p-value for what? For each. And that means that is what? Is less than 0.05. That means that H is what? Is significant in determining what? In determining fear. Multiple regression. So multiple regression, we have X to be DF, then this H sibling, then we have what? Patch. So S, we have 3 variables for X, and we have Y, we have 1 variable for Y, fear. From there, we now perform the model. This is the model. Then from there, we now have these results. So the results, you can see, how do we interpret it? What is the p-value? P-value for the H, 0.00. P-value for SP, that's 0.00. And also the third one, the same thing. So that means they are what? They are statistically significant, and they can contribute to what? And they can contribute in determining the what? The fear. The fear. So now regression problem in machine learning now. We now go to machine learning regression. Under the machine learning regression, we have several of them. There are very many. We have KNN, we have random forest, we have as many as possible. There are very many. So now the first one we have to do is what? Is that we are going to select feature for the regression. And that feature is what's called X. It's called DF bracket H, SP, and patch. Then Y is called the word fear. Then we now train it. S train, S test, Y test, Y train. So we now train it. We choose the test state to be open 2, and we choose the word, the random state to be for the 2 present 2. So the next thing is to bring it up here. Then we run this code to give us how the one we have trained will look like. This is how to look like. Then after that, we'll now put the model itself properly. But then we model, so we have the regression, and when we have the regression, then we have our results to be this. And also we have the mean square error, the mean absolute error, then we have root mean square error. All these ones, they are to determine when we are comparing 2 or more models, the one that has the lowest value we consider as the best or as better one. So these are the values for mean square error, 111.773 means. So mean absolute error, that is MAE, then root mean square error. So the same thing, here way. Also, we have plots. You can do the plots of actual and predicted ages. These are plots. And also, we can calculate the test. Then also, we have KNN regression. KNN regression. So you also have a split. You split it also. Then you have the regression. Then after that, after the regression, then you have a what? Your M.Sc, MAE, and the root M.Sc. And from there, there are several metrics available. We have more than 3 metrics. You can use your own exam. You can use more than 3 metrics. So it's not compulsory. The more opportunities you explore, then the higher your score will be in the exam. So please take note. Take note of that. So I'm just giving you this guide. So now with this, now you can see you have this random forest also. We have done it again, we have done the random forest now. So random forest as well. Then also classification model. Classification. So we are done with the regression now. Without regression, you can see you have 117 here for the M.Sc. You compare the 3 of them. The one that has the lowest value for M.Sc, root M.Sc, and so on and so forth will be considered as the best among them. Then we go to classification model. Any question, please, before I move on to classification model? Any question, please? Can we have any question? Before I move on to classification model, any question, please? Let me welcome questions, please. Any question? Are you there?
Good afternoon, sir.
Good afternoon to you, sir.
Yes, sir. Please, looking at this, please, I don't know if I am still jumping, but I want to know, because this is, we have developed some models like this. So how can I relate this to cloud computing, please?
Maybe you're just joining us. I've said that from the beginning. I said by the time we are done with this machine learning, we are going to develop this machine learning in the cloud.
Okay. Noted, sir.
Cloud. So by the time we get to the cloud, we are going to develop this. This model will be developed into web app. And by the time it becomes web app, that's coming from the cloud, from the Streamlit. Streamlit is a cloud, cloud mechanism where we develop any algorithm and put in the cloud. So anytime you click on it, it will come up, then you enter your result or your data, give you the result you want.
Okay.
All right.
Noted, sir. Okay. Thank you, sir. Yes, sir.
Any other question, please? Any other question? Okay, if there's no question, then we'll move on to classification. Under classification, we make use of the same data sets. That's why I use the word df1 is equal to df.copy. That is, I copy everything we have above. Everything we have from beginning, from the above, I copy it down here. Then from here, I now have column, arrive, P class, and back. Then we drop df.drop. We drop column with S is equal to 1, then in place true. So we drop these columns. We drop all these columns, we drop them. We drop them to the df now, df.head. You can now see all the columns we have dropped do not appear here again. We want to do the classification. The next thing is encoding. All this, you must have been taught all this in your previous classes by other tutors. So I'm just trying to refresh your brain back to them, that this continuous work. So encoding, column 2, 0, 1, 2. Column 2, this is male. We want to encode male. Column 7. So column encoding means that I want to make them to become categorical, categorical value instead of all these objects. So now column 7, this 0, 1, 2, 3, 4, 5, 6, 7. That's who. Want to make who, man, woman, man, and so want to encode it as well. So that's what I've listed here. you can see what I want to encode. So that's column. Now you don't come here, you like use that column here. Cover code. When you use code here, it means that you have already defined the code here. So the system will go to that code and encode it. What is the code? You can see what says go to 1. 1 is for what? 1 is for male, 0 female. Can you see 0, 0, 0, and 1 and so on? Can you see now? It has become real figure. So I've become real figure. So we can now move down again. You want to make use of Y to be survived. You want to make use of 5 survive as your target variable, and your S will now become other ones. So you write the code to split. After splitting, the next thing is what? Is to now develop the what? The results here. So from there, we move down to the train one, while we have what? The test. So now fit the model. Logistic model is the first one we are fitting. This is the model, and these are the accuracy. So under the classification, we don't make use of M.Sc, MAE, with square error there. Under the classification, if you want to determine which model is the best, we use metrics such as accuracy, such as F1 score. We make use of F1 score. We make use of confusion matrix, and so on and so forth. So these are the ones we make use of. Can you now see? So this is the results, F1 score, and so on and so forth. Can you see? Random forest, the same way, the same process for random forest. We do the same process for random forest. And also, we have what? We have another one, division tree, classifier, the same process. Look at data accuracy, so on and so forth. Then you will move down to the diagram. They will now move them with that. Can we now say LR, RF, random forest, division tree. Look at the accuracy percentage, and model score. From this one now, you can yourself, this is code I wrote. This is code I wrote to develop this table. You can use the same code to develop your own. So you can see, out of this now, which one has the highest? I think it should be what? Logistic regression has the highest. That's how to explain it. Because it's one has the highest value. The one with the highest value here is considered as the best. So out of all this regression, all this regression now, classification now, logistic regression is the best. So any question? That shows the end of our class. Any question, please? That's question. I'm waiting. Is there any question, please? Any question? Okay. Abioye, Salvation, Prof. Joseph. Any question, please?
No, for now, sir.
Okay. If there's no question, so this shows that.
I have a question, sir.
Okay. What's your question?
My hand is raised. Yes, my question is, I hope we are going to have access to this particular, maybe the notebook that you are using, sir, so that you'll be able to study better. Because some of us don't have statistics and background, so we just have to do extra work.
Oh, sorry about that. I thought I've shared this in my WhatsApp group for the cloud computing.
Yes, it's on the WhatsApp group. It's on the WhatsApp group. On the WhatsApp. Mr. Jadi, it's on the WhatsApp group.
So maybe I'll still share it again in the cloud, in the cloud.
Okay, thank you, sir.
All right. Other questions, please. Comments? Adenike Ayola. Edward.
Joseph is talking.
Okay, Johnson.
Yes. I wanted to ask, this accuracy scores, does this serve the same purpose of when we talk about this,
F1 score? Hello? I can't hear you. Hello, I can hear you, please. Okay. Another person. I can see some hands up. Adana, what's your question, please?
All right. Thank you so much. Mine is not a question. Thank you. I appreciate your efforts. But I want to find out, is it possible for us to have this recorded video? Is it possible, sir? Because some of us joined it, like I joined it, so I wish that we have it enable us, understand what was taught today.
Please, I think I am
Is
recording.
it possible for you to send us the recorded video?
Yes, it's possible. I am recording already.
You. Thank you.
All right. So, any other comments or questions? So, if there's no question, I think we can bring the class to an end. So, thank you very much. On behalf of Osiri University, Nebraska, and the US, I want to appreciate everybody for being with us and for following this class to this moment. Thank you very much, and God bless you all. Do have a pleasant day, and God bless you.